Welcome to Chemistry Lab! But before we start having some real fun, let's cover some of the basics.
Safety first.
Approved eye protection must be worn at all times. Make sure it protects from the sides as well as the front. Appropriate clothing must be worn to all labs. This includes closed-toed shoes and pants. Bunsen burners require caution. Good housekeeping promotes safety. Clean up your lab bench as you go. Eating, drinking, and smoking are not allowed in the lab. Be familiar with the location of safety equipment. The first aid kit is typically found by the door. Inside of it, you will find bandages, band-aids, gauze, hydrocortisone cream, scissors, a lot of other good stuff. The eye wash station is located at the front of the lab. To operate, just pull out, point at your eyes, and squeeze. Don't forget to remove your safety glasses. If you happen to be on fire, you can use the safety shower by standing under it and pulling this handle, or the fire blanket by merely pulling this and revolving it around your body. Only authorized experiments are allowed in the lab. No one is allowed in the lab without an instructor. No children or animals are allowed in the lab. MSDS sheets tell you everything you need to know about a specific chemical. They can be found over here. If you are using chemicals in the hood, please leave them in the hood and fill only a small portion and take back to your desk. Also, make sure that this is kept at a low height so that air is sucked in and nothing comes out. You will notice at the entrance of every lab there is an MSDS key. It explains the health hazard, fire hazard, specific hazard, and reactivity of every element or chemical. Notice distilled water is 0 for everything. On the other hand, notice ethyl alcohol is highly flammable, given by the number 3 for fire hazard. It is your job to read through the lab manual before each lab. All right, now let's get into lab 1. Okay guys, so first we're going to do mass determination. So we're going to weigh small objects. I was going to weigh this elephant, but it turns out that it's a little bit too heavy. So what we're going to do is we're going to weigh this little part of the mortar and pestle. So you would normally crush chemicals in here, but so we're going to weigh this first by itself. So we're going to try to weigh the pestle, and so we're going to do it in 3 steps. The first step is going to be weighing it by itself on the scale. Now normally you would not want to do this. It covers why in the lab manual, but so we get a reading of about 62 grams by itself. So then you're going to do the difference method, which is weighing the beaker, recording that weight, so 140 grams, and then weighing the beaker plus the pestle, and we get about 202 grams, so you subtract 202 from 140, and we get about 62, which was our original weight, and you'll have to do this with 3 different objects. And now there's a really cool way to automatically, or without having to calculate anything, to do the difference method. So when you place this beaker on your scale, see this little T button right here? 0\T, that stands for either zeroing the scale or tearing the scale. And so when we click that, you'll notice that our new weight has now become 0 grams, even though there's a beaker on our scale. So now that will allow us to determine the weight of the pestle without having to do any calculations. So notice it's 62, which is about what we've been getting for the using the difference method without tearing. Okay, so that covers how to do mass determination. Now let's move on to volume. And remember to look over the lab manual for additional notes on weighing. For example, I put this Erlenmeyer flask in the freezer. Okay, so this Erlenmeyer flask right now says it weighs about 70.571. You're going to notice this weight keeps going up because what's happening is the air around that Erlenmeyer flask is touching the flask, which is very cold, and the air is therefore falling to the ground. So as the flask warms up, that air is no longer going to be falling onto the scale, and you're going to see that the weight then becomes, well, what appears to be lighter. And so that's why you want to always have objects at room temperature. Still going up. Okay, so now let's do volume determination. Now don't forget to read the notes in your lab manual on volume determination. There's a nice section that covers some good tips and tricks. So we're going to start by weighing our beaker once again, and then we're going to add distilled water to the 25 milliliter mark. Now, if you take a quick look at this beaker, you'll notice that the 25 milliliter mark is right there. It's kind of difficult to gauge exactly where that will be, but let's if we go ahead and fill that up and then try to weigh how much that would be. So this is where we're filling it up from distilled water. So you'll notice the big 000, that typically implies water, but not always. Okay, so we want to fill it to the top of the meniscus, or to the bottom of the meniscus reads the 15 milliliter area. And so the meniscus, if you take a look at the water level, there's kind of a little bit of a curve to it. And so the bottom, that's called the meniscus, that curve. So the bottom of the meniscus would be the bottom of that little curvature. And you have to try to be flush against the level of the cylinder in order to really get an accurate reading. So you want to get down low and really look at the meniscus. So that is how you accurately measure volume in a graduated cylinder. Why is it called a graduated cylinder? Well, it's got these gradual marks, and it's a cylinder. Okay, guys, well, that's the end of today's lab. Good luck, and welcome to chemistry!